Today we're diving into the fascinating world of protons. You might have heard the word proton in your science class or seen it in textbooks, but what exactly is a proton? Why is it so important in the universe? In this video, we'll break down everything you need to know about protons, starting from the basics and moving into more interesting details. By the end, you'll have a clear understanding of what a proton is, where it's found, and why it matters. Let's start our journey by looking at the building blocks of matter. Before we get into protons, let's quickly review what atoms are. Atoms are the tiny units that make up everything around us, from the air we breathe to the food we eat. Each atom consists of a nucleus at its center, surrounded by a cloud of electrons. The nucleus itself contains even smaller particles, including protons and neutrons. Understanding atoms helps us see where protons fit into the bigger picture of matter. So what exactly is a proton? A proton is a tiny particle found in the nucleus of every atom. It carries a positive electric charge, which plays a crucial role in how atoms behave and interact. Without protons, atoms wouldn't exist as we know them. Protons are one of the three main subatomic particles, along with neutrons and electrons. Let's explore what makes protons unique. One of the most important things about protons is their positive electric charge. This charge is exactly equal in strength but opposite in sign to the negative charge of electrons. Because of this, protons help balance out the charges in atoms, making them stable. The positive charge of protons also means they interact with other charged particles in interesting ways, which is key to how atoms bond and form molecules. Protons are always found in the nucleus, which is the dense center of an atom. The nucleus is like the heart of the atom, and protons are a big part of what makes it tick. Alongside neutrons, protons give the nucleus its mass and help determine the identity of the atom. The number of protons in the nucleus is what makes each element unique. Every element on the periodic table is defined by its atomic number, which is simply the number of protons in its nucleus. For example, hydrogen has 1 proton, so its atomic number is 1. Helium has 2 protons, so its atomic number is 2. This number is like an ID card for each element, and it's all thanks to protons. Inside the nucleus, protons aren't alone. They're joined by neutrons, which have no electric charge. While protons determine the element, neutrons help add mass and stability to the nucleus. The balance between protons and neutrons is important for the atom's overall stability and behavior. Protons and electrons are like two sides of a coin. While protons are positively charged and found in the nucleus, electrons are negatively charged and move around the nucleus in a cloud. The number of protons and electrons in a neutral atom is always the same, which keeps the atom balanced. Protons are tiny, but they're actually quite massive compared to electrons. In fact, a proton is about 1,836 times heavier than an electron. Most of an atom's mass comes from its protons and neutrons, with electrons contributing very little. This makes protons essential for giving atoms their weight. You might be surprised to learn that protons themselves are made up of even smaller particles called quarks. 3 quarks held together by strong forces make up a single proton. This structure is what gives protons their unique properties and stability inside the nucleus. The strong force is what holds the quarks together inside a proton, and it's also what keeps protons and neutrons bound tightly in the nucleus. This force is the strongest known in nature, and without it, atoms wouldn't be able to exist. The strong force is a key reason why protons are so stable. The proton was discovered by Ernest Rutherford in 1917 during experiments with atomic nuclei. Rutherford's work helped scientists understand the structure of atoms and paved the way for modern physics. His discovery showed that the nucleus wasn't just a solid ball but made up of smaller particles like protons. Protons might seem like abstract science, but they're actually part of everything you see and touch. Every object, living thing, and even the air is made of atoms, and every atom has protons in its nucleus. Without protons, the world as we know it wouldn't exist. In chemistry, protons play a huge role. The number of protons in an atom determines how it reacts with other atoms. Chemical reactions often involve the movement or sharing of electrons, but it's the protons that define what element is involved in the reaction. In physics, protons are studied to understand the forces that hold matter together. Experiments with protons have led to discoveries about the universe, from the Big Bang to the structure of stars. Protons are also used in particle accelerators to explore the smallest parts of nature. Did you know that protons are used in medicine? Proton therapy is a type of cancer treatment that uses beams of protons to target and destroy cancer cells. This advanced technology allows doctors to treat tumors with great precision, reducing damage to healthy tissue. Protons aren't just found on Earth, they're everywhere in the universe. In fact, protons are one of the most common particles in the cosmos. They're found in stars, planets, and even in cosmic rays that travel through space. Protons help shape the universe as we know it. Hydrogen is the simplest element, with just 1 proton in its nucleus and 1 electron orbiting it. This makes hydrogen a great example for understanding protons. In fact, a single proton is sometimes called a hydrogen ion when it's by itself. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. Protons always stay the same for a given element, but neutrons can vary. This gives rise to different forms of the same element, called isotopes. The number of protons and neutrons in a nucleus affects how stable an atom is. Some combinations are more stable than others. If there are too many or too few neutrons compared to protons, the atom can become unstable and radioactive. Protons play a key role in electricity. When atoms lose or gain electrons, they become ions, but the number of protons stays the same. The movement of electrons creates electric currents, but it's the protons that define the identity of the ions involved. In nuclear reactions, protons can be added or removed from nuclei, changing one element into another. This is the basis for nuclear power and the energy produced by stars. Protons are at the heart of these powerful processes. The periodic table is organized by the number of protons in each element's nucleus. This makes protons the key to understanding how elements are arranged and why they have certain properties. Every step across the table means adding one more proton. The mass number of an atom is the total number of protons and neutrons in its nucleus. While protons define the element, the mass number tells us about the atom's overall size and weight. This is important for understanding isotopes and atomic structure. For every particle, there's an opposite. The antiproton is the antimatter version of the proton with the same mass but a negative charge. When a proton and antiproton meet, they annihilate each other, releasing energy. This is a fascinating area of physics research. Particle accelerators are machines that speed up protons to nearly the speed of light and smash them into other particles. These experiments help scientists discover new particles and understand the fundamental forces of nature. Protons are often the star of the show in these high-energy collisions. Cosmic rays are high-energy particles from space, and many of them are protons. When these protons hit Earth's atmosphere, they create showers of other particles. Studying cosmic rays helps scientists learn about the universe beyond our planet. Nuclear fusion is the process that powers the sun and stars. It happens when protons combine to form heavier elements, releasing huge amounts of energy. Understanding fusion is key to developing new energy sources for the future. Nuclear fission is another process involving protons, where heavy atomic nuclei split into smaller parts. This releases energy and is the principle behind nuclear power plants. Both fusion and fission show how protons are central to powerful energy sources. Some atoms are unstable because of their proton and neutron balance. These atoms can undergo radioactive decay, changing the number of protons and transforming into different elements. Protons are at the heart of these changes. Shortly after the Big Bang, the universe was filled with energy and particles, including protons. These protons combined to form the first atoms, setting the stage for everything that followed. Protons have been around since the very beginning of time. Stars are giant balls of gas, mostly hydrogen, where protons fuse together in nuclear reactions. This fusion releases light and heat, making stars shine. Without protons, stars and life as we know it wouldn't exist. When massive stars explode, their cores can collapse into neutron stars. These stars are made almost entirely of neutrons, but they started out with lots of protons. The transformation from protons to neutrons is a dramatic process in the universe. The number of protons in an atom determines how it bonds with other atoms. This is the basis for all chemical compounds, from water to DNA. Protons set the stage for the diversity of matter in the universe. In chemistry, acids are substances that can donate protons to other substances. This process is called proton transfer and is central to many chemical reactions. Understanding protons helps explain why acids behave the way they do. Bases are substances that can accept protons. The interaction between acids and bases is a fundamental part of chemistry, affecting everything from digestion to industrial processes. Protons are at the center of these important reactions. The pH scale measures how acidic or basic a solution is based on the concentration of protons, hydrogen ions in it. A low pH means lots of protons, while a high pH means fewer protons. This simple idea helps us understand everything from lemon juice to soap. Every living thing depends on protons. From the DNA in your cells to the water you drink, protons are involved in countless biological processes. Life as we know it wouldn't be possible without these tiny, powerful particles. Modern technology, from medical imaging to nuclear power, relies on our understanding of protons. By studying how protons behave, scientists and engineers have developed tools and machines that improve our lives in many ways. Research into protons continues to reveal new mysteries about the universe. Scientists use powerful machines and creative experiments to learn more about these particles, hoping to unlock the secrets of matter and energy. As technology advances, our understanding of protons will lead to new discoveries and innovations. From clean energy to advanced medicine, protons will continue to play a central role in shaping the future. Let's recap what we've learned. A proton is a positively charged particle found in the nucleus of every atom. It defines the identity of elements, helps hold atoms together, and is involved in countless processes in science, technology, and everyday life. Protons are truly fundamental to our universe. Without protons, there would be no atoms, no elements, and no matter as we know it. Protons are the foundation of everything in the physical world. Their unique properties make them essential for the existence and diversity of the universe. Think of protons as the building blocks of matter. They combine with neutrons and electrons to form atoms, which then make up everything we see and experience. Understanding protons helps us appreciate the complexity and beauty of the universe. Thanks for joining us on this journey into the world of protons. From their discovery to their role in the universe, protons are truly remarkable. As science continues to advance, who knows what new secrets will uncover about these tiny, powerful particles? Stay curious and keep exploring the wonders of science.